and you guys are 8 over there. All right. So I will call out a group number. You have to give me the answer, whether it's right, wrong, left, or indifferent. All right, randomly chosen. It is going to be group number 6. How? It's called a random number generator. Well, it's not an app. It's just online. It's called a true random number generator. All right. So, group 6, what do you got? Excuse me, your group is going to be chosen next randomly. I just need to hear what they're saying. What is it? 10 and negative 5th? All right. So, let's see who we got next. Group 7.
For part B?
For part B, yep.
We got 0.140. 0.14.
Like that? All right. And what are the units for that? Molarity. All right. All right. Big M. Big M. All right. Cool. All right. So let's see how these groups did. Is there anyone that would like to, first of all, argue a different answer for A or B? That's group 1.
No. For H, I believe it's 1.12.
Like that? Okay. All right. So difference is opinion. Yeah. How many stick figs do we have?
Okay, never mind. Yeah, see? Don't listen to him.
This is group 1's answer. Yep, Group 1, all 4 of you in group 1. All 4 of you are responsible for that. All right, here we go. Let's see how we did. 5, 4, 3, 2, 1. Nice job. Congratulations, Alpha and Beta. We got it. Now, any questions on how to go about this? Okay, A, B, any questions about how this is going? All right, so substituting in here. Question, clarification, yeah? Yeah? All right, good question on that one. How do you know OBR? Okay, this is a unique thing you can do here. If H plus, let me see if I can write up here. The reason you know OBR, if you know the concentration of that here, and if you say that is equal to a certain amount, let's say X, the ratio between the two is 1 to 1. So if that's X, that will be equal to X. So that's a little trick you can use, the molarity. Now, this is because we're not changing the volume at all, so we can do that with molarity or moles in this case. We don't know, we know the concentration of the H plus concentration, so that's why those two are equal in the equation.
Wait, Mr. Christopher?
Yeah?
So if you were changing the volume, like if you were adding like 7 milliliters of the one solution and 7 milliliters, you have an ice cube then?
Yeah.
So
Yeah, that's how I would approach it.
you would not be able to just like say, oh, there's one of these, there's one of these.
Correct. Yeah, you would. That's how I would approach that. Yeah. All right, here we go. So we've got group. All right. Yeah, we got group 6 and darn it, I didn't write down the numbers, but good job. 6 and 7. Playing for food. All right. Who's keeping the score? You keeping the score, Lochin? to remind you that you were chosen randomly?
You got it right though. Oh, let's play Jeopardy!
Yay! All right. If you what? U.S. history. Yeah. Oh man, I love it. It's so much fun. I love that game. I'm not going to invent it for chemistry. I actually invented one for chemistry once, and no, it's just it doesn't matter how you approach a chemistry problem. It doesn't make it more fun. I mean, it does make it a game. All right, C. You got 3 minutes. On your mark, get set. Randomly chosen in 3 minutes. Go. And I'll be honest, I don't know if you can do this in 3 minutes, but good luck.
Is this connected to the...
It's connected to the previous problem, of course. Hopefully you wrote that down. Does anyone need the equation? No. Well, my friend Sherry will be proud of you. It's okay. I'll call it Lashalala from now on too. It's more fun. All right, hand up if you're ready. Your group's ready? That one group ready? Yeah.
30 more seconds.
Few more seconds. Okay, I'll give you a moment while my random number generator warms up. All right, you guys ready? Here we go. First group, randomly chosen. For the answer for I, again, you got to give me an answer. There's no penalty if you're wrong, of course. All right. For C, I, the group is group number 4. Group 4, any answer you choose. Calculate the volume needed to reach the equivalence point. 1,337 milliliters. All right. Next group, for double I. Is it 4 again? No, it's 7. Group number 7. You guys are group 8 over there. Basic.
So greater than 7.
Greater than 7. All right. All right, now we're going to go back to I because I have a feeling 1337 might be a little high, but I mean, it could be right. Group number 1. Milliliters, yep. 0.0052, all right. Better answer over here. 41.2, group 7 says. Group 8, what do you say? 82.5. All right. Group 2, what do you say? 41.3 milliliters, I'm assuming. All right. I shouldn't assume, no. All right. And then part 2, anyone have a different answer besides less than 7? Yeah, what group are you? 6?
Oh, no. We were just saying, you said less than 7. Yeah.
Oh, I'm sorry. They did say less.
No, they said greater.
Oh, they did. Okay, I said the wrong answer. All right. Anyone else? Okay. So let's check and see how we did. Winners, winners. 41.3 milliliters.
On the AP test, we get 0.1 for rounding error.
Rounding error. On the AP test, I'm fine.
We did get that.
Who won? All right, looks like the best answer was group 2. And this one looked okay. All right, if you're in group 4, 1, or 8, look at what you might have missed. 8 was close. You guys were close. Group 4 and 1, I don't know what they did, but they should be able to figure it out right now. All right, so next one is pH is greater than 7. I'm okay with that. This is just the AP answer key for you. Yeah, I think that would be, yeah, that would probably be fine, yep. This is just a couple ways of going about doing it. this one. They were doing the KA-KB relationship. KW equals KA times KB. To get the KB. But yeah, Ed, you could use Henderson-Hasselbalch. All right, here we go. D and E. 3 minutes. 3 minutes. Okay, in 3 minutes, we will randomly choose a group for D and E. D and E. The equation is on the bottom in case you need that again. You have 4 people in your group, hopefully, that you can ask them. If you have no idea, you can ask another group where to start. You have Kevin. What about the other 2 guys on the other side of the table?
I'm not aware of their existence. I have no idea who they are.
Don't like the timer? There you go. No timer. Timer's gone. Timer's gone. Okay. Then we might need more 3 minutes.
Oh, there's the equation. Oh, wait. Right?
chosen group.
We volunteer.
Volunteer? Nope, no volunteers, but I will randomly choose your group eventually.
We already, like the first time we got chosen, we had to go.
Oh, yeah? I'm sorry. All right. The randomly chosen group, first group up for D. For D is group number 4. Group number 4. What's up? Still working, okay? So you need number of moles. So pick a number. D. I'll get back to you. Next randomly chosen group is 2. Group 2. 0.02. Okay. Next group. 4 again. All right, E, number 7. Group number 7. That's not you. Group number 7 is in the back. You're group number 6. Yeah, group number 7 got picked again. So E, why is HOBr is a weaker acid than HBrO3?
HBr3 has more oxygen.
Uh-huh.
I think its oxidation state
Uh-huh.
makes it so that it
More electronegative, okay? Or less. Okay, that's all right. You're on the right track. All right. Another group to try E out. Another group to try E out. I know you're not done. I'm stopping you. Group 3. Peace. Uh-huh.
Okay, we got it. We got it.
Hey, excuse me, I'm listening to somebody talk, so shut your yappers. Shut all your holes, please. You can close your eyes too if you don't want to listen. Yeah, what's up? Uh-huh. Okay, H plus comes off easier. And we all support that. Excellent. Good job. All right. All right. Any other group for D? D's answer. Group 4. What do you think, group 4? Not yet? Yep.
We have a different answer. We're not sure if it's correct, but we got 0.0092.
0.0092 moles. All right. So you guys are group 7 there. Different answer, okay? Anyone else with different answers? We'll write down any different answers we get. Any other groups that want to write their answer down? Group 1 agrees with group 2. Okay, you guys are both happy about that? All right. All right, so we're going to check our answers now for D and E. D and E. The correct answer for D is 9.2 times 10 to the negative third moles. And the correct answer for E is the HO bond is weakened or increasingly polarized by the additional oxygen atoms. So if you said oxygen was more electronegative, okay, that is it's polarized. So electronegativity is what makes it polarized. So that is in the same area. I don't know how specific they would be, but that is why any of those explanations would be acceptable. So
So, is it trying to say that the H can break away more easily than HBr3?
correct. The H plus. Yep. H plus can separate easier because the electrons are found on the other side of the molecule. It's more electronegative. This side's more electropositive. Because it's more electropositive, it's easier for that positive hydrogen ion to separate out.
If the electrons are all on one side, and it's like that makes it more closer to an ion because it's like it has a longer dipole moment and all that.
That's an interesting point. But you're trying to separate out the H plus Lochin. Lochin, you're trying to separate out just the H plus, not the H. So because of that, it already has a positive charge, so it's easier for it to be removed. It doesn't make a stronger bond between them. It's easier for it to be removed because it already has a slight positive charge on it. So when you remove it, an ionic bond, yes, it would become like an ionic bond with an H plus and the BRO3 on the other side. When it goes into solution, they separate completely. That's why it's weak. But because of its polar, this is more negative, this is more positive, it's easier for it to separate. So ionic bonds are strong, but when they're put in water, they separate easier. They dissociate. So that's the problem, or the challenge of that stronger bond. All right, we're going to take a 30-minute water break, stretch break, before the next competition. 30-second. 30-second water break.
30 minutes.
Yeah, 30-minute, yeah.
Why does volume remain constant?
All right. The group that gets the most of these correct is free to not answer the next question. Okay, so raise your hand with any answer you have. I will call on you for any of these. I have 1 in 5 chance. So you can give me the answer to any of them. You just say the letter and what the answer is you think, and I write it down with your group number. So you can raise your hand as soon as you have any of the answers. Yes? Okay. What group are you? Oh, Lochin said something out loud? Well, if you raise your hand and I call on you, you can get credit for whatever someone else says. Yes, sir. B, J, strong base. Okay. Medea. C, what group are you?
Whoa, raise your hand.
Yeah. What group are you? What group are you? 3. Yep. What group? 2? Yep. H is what? I'm sorry, buffer? All right, you're number 6, right? Buff. All right. Yeah. Okay. Charlie?
A is weakly basic and I is strongly basic.
Wait, Charlie was on the wrong team. That's so Charlie has no answer? Okay. Yeah. Uh-huh. All right, that didn't count. Yeah. Didn't count. I called on Charlie and he didn't have an answer, so. Next, yeah. D is a buffer. Okay, what group are you again? 3? 3, buffer. Okay, Megan?
Back to I. It's a
Strong
strong base.
base.
And A.
I can't give you 2. Yeah. G neutral. Group 4. Neutral. All right. Jamie? A is a weak base. Your group 7. Weak base. Okay. Well, you can disagree with one of them, obviously. Robert? G you think is a weak base. Okay. Group 2. Weak base. Okay. All right, so let's check our answers. Oh, one more dispute. Yes? That's a great question. So you're group 7? Should we minus points if they get it wrong?
We said no. We changed our mind. I raised my answer from
Well, I'm not going to penalize for wrong answers right now, but let's see. Yeah. Neutral for all of them. All right. Smart move, buddy. 4, neutral. All that haven't been sent yet. So anything that's neutral, you guys win. All right? Here we go. Hey, only one smart American in here, okay? Smart astronaut. Only one smart astronaut in here. All right. All right. Weak base. The first one, weak base. Okay, 7 gets 1 point. Now, Jamie, you need to keep track on another scoreboard because it's a little different.
She's a part of a group.
Yeah, she's not a cheater.
Charlie's not. No, we're being fair.
She won't cheat like you.
Send it to
Okay, I know how you work, and I would cheat too, but she's not going to. Okay, 7. Strong acid, group 1 gets a point. Weak acid for C, group 5 gets a point. D is a strong acid. Group 1 gets a point. It is not a buffer. Let me cross that out. No buff. All right, E is neutral. Group 2 gets a point, but 4 does not. Sorry, Group 2 gets a point. F is a weak base. All right, F is a weak base. So no one got that one. G is a weak acid buffer. A weak acid buffer. So G, a weak acid buffer. And we saw no points on that one. Is that right, G? All right, and then H. H buffer. Should we give that to him? Yes. Yeah, 6 gets a point. Strong base. 7 gets another point. And J. Yeah, technically speaking, 4 gave 2 answers for this one. So you guys scored a point because you said it was neutral as well. So that was wrong, that was right. All right, 1 point for group 4. All right, good job. Now, the one that is kind of a little weird people look at is G. Okay, the question is, well, why would it be a weak acid buffer? Okay, why would it be a weak acid buffer? What's going on here? What do you notice about these two here? It's a weak acid and it's a strong base. But what else do you see about them? Okay, all right, there's more of the weak acid. Okay, it's more of the weak acid. Okay? So because there's more of the weak acid, okay, it creates a neutralization which creates a salt. So as it neutralizes, it creates a salt, and that salt creates a weak acid buffer. Okay, so that is a AP special. That's order me up one of those on the AP test because they will give it to me. They really like things like that. They really like it. They really love it. It's like their favorite buffer problem in the world because they put a KOH in there and they think, oh, it's a base, it's a base, it's a base. So just be aware of that. Yes?
Do you understand why J is neutral? Because copper nitrate, like in water, is a strong acid, so that's a weak conjugate base. And then sodium hydroxide is a strong base. So that tracks the base.
Yeah, I'm not sure about that one. Oh yeah, that's okay. Yeah, that one, I forgot about that one. Explanation here for J, the reason why is because when the copper nitrate reacts with the sodium hydroxide, it produces a solid copper hydroxide. So because it makes a solid, it removes all the hydroxide from the solution. So the solution then becomes neutral because there's no extra hydroxide, no extra hydrogen ions.
The nitrate is still there.
Yeah, the nitrate is an ion. It does not make it more acidic because it doesn't have the H. Unfortunately, it would not make it more basic because of this neutral material here. So the nitrate by itself would not do anything. Just nitrate by itself does not change the acidity. Right. That's why you can have sodium nitrate. It's neutral. Sodium nitrate is neutral. It's a salt. It will not change the pH of it. No. It's got to be H. It's got to be HNO3 in order for it to be the strong acid. If it's just NO3, it's just a nitrate ion. But it won't remove the H's if it's just nitrate. You could think of it, it removes the H's and it loses the H's. It does both. The nitrate is strong, so it doesn't connect to any H's. It stays as an ion, floats around the solution. So the nitrate floats around the solution, the water floats around the solution. If the a nitrate with a negative charge attracts a positive proton, it's a strong acid, so it separates immediately. And then that proton goes back to the water, goes back and forth. It's at equilibrium, like water. It's not a strong acid. You didn't have nitric acid, you had copper nitrate. There's no H in here. There's no H. It's not an acid. NO3 does not make nitric acid. If you stick NO3 in water, it's neutral. All right, here's number 2. Number 2. All right, which team got the most on the last ones? 1 and 7. So 1 and 7 do not have to answer this question, but everybody else does. You got water and you got nitrate on it. You got nitric acid, put it in the water, it separates. Can't do it experimentally if you don't have data. So you have to do it based on the All right, ladies and gentlemen, let's check our answers now. Again, your group only has to say which of the following mechanisms can be ruled out. You only need to say one mechanism. There could be more than one, or it could be less than one, I guess. Technically, although I hope there's one of them. So the group that's chosen is group number 4. Wow. Rule out number 1, group number 4, all right? Next group chosen is group number 5. You want to choose 3 and 1. All right, 3 and 1. Okay. Other groups that haven't responded besides the ones that are omitted from doing this. Yeah? You want 1? You want 1? You guys are group 6. Anyone else I haven't chosen? Group 2? What are you going? I? 1 and 3. Wow. I and triple I. All right. All right, let's check and see how we did. We got some I's, we got some triple I's. I hope 2 isn't the answer. That'd be a bummer. All right, let's look and see. Mechanism 1 can be ruled out. Okay, the steps do not match the equation when added up. Okay, the rate might work, but the steps don't work. All right, so mechanism 1 does not work. You're absolutely right if you chose mechanism 1. Mechanism 2, it matches the rate law, but a term molecular elementary step is unlikely. So it's unlikely for mechanism 2 to actually happen. Term molecular means it's got 3 things coming together in the elementary step, the first step. Yeah. So this one here, it matches the rate law. So can't rule it out yet. But mechanism 3 is the best choice. So mechanism 2 and mechanism 1 should have been ruled out. Mechanism 1 by its equation, and mechanism 2 because of a term molecular elementary step. Mechanism 3 matches. Okay, best choice here. If we cancel out the intermediates, there's this and this. N2O, N2O. We've got our equation, 2NO plus 2H2. Okay, that produces our N2 plus our 2 H2Os. The slow step here is the rate determining step. So the rate determining step here should match up here with the 2 H's. Here's our 2 NOs, our H's, and our H's there. Whoa, that's weird. That doesn't look right to me. Why is it an H2? Alright, that's a typo on here. Well, the 2 here, the 2 is supposed to be down at the bottom. That 2. It's just written in the wrong place. Okay, so you might have thought it was supposed to be H2 squared. Okay, I apologize for that. So the H2 here, this one, this H2, and these 2 NOs are involved with the rate because that's the slow step. What's below it is not involved with the rate. So that's why it's K times the H2, not squared, and then the NO is squared because of the 2 coefficient there. Yeah. Yeah, mechanism 2. Term molecular is there's 1 here and 2 here. So there's 3 things coming together in this first step, and that's highly unlikely for that to occur. The first step, the elementary step. It's unlikely. Once you get past that first step, then it's possible it could happen. Yeah. It's possible, but unlikely. No. It would wrap. Yeah, the probability is incredibly low because you have 4 ways, but you also have 3 dimensions to work with. So you need the collision to happen. If you're on a flat plane with 4 cars, it's more likely. Here you got, and you have to have the right geometry of the spin. Cars can hit at any angle. Molecules, when they collide to react, have to hit at the right angle and the right velocity. little more practice with order of the reaction. So here's some experimental data. You guys know experimental data is key for rate determination. So determine the order of the reaction with respect to each reactant listed below. Group midterm. All right, ladies and gentlemen, I realize we are near the end for some of you. So what we're going to do is we'll look at how to go about solving this problem. Okay, the rest of these problems, again, will be on YouTube for you to check the problems and the answers. So we're going to go to the next one here. Yeah, all the stuff we did was recorded. Oh, I know. So, all right. So for this one here, you take the, what experiment would you choose? For I minus, what experiments would you choose? With respect?
Define I minus.
Okay. So to find the I minus, use first and second. Okay, COO. Second and third. All right. Second and third. All right, so let's look at how to go about doing this problem. We set up from experiments 1 and 2, the rate 2 over the rate of 1. This gives us the 3.05. And again, our Y's cancel here, our CLOs cancel. And we're left with our 0.052 over 0.017. And therefore, the ratio is 3.1x. Therefore, x is going to be equal to 1. It's going to be first order with respect to I. And then looking at experiments 1 and 3, okay, it's going to be first order as well with respect to CLO minus. So that gives us the relationships here for the two relationships here, 1 and 3 for CLO and 1 and 2 for I minus. Now, once we have our calculations, we should be able to get the rate law. Here's the steps for getting the rate law and for getting the specific rate constant. So you solve for the rate law, then you plug back in to that for double I. Then if you look at the analysis of the data, the graph above was produced. Okay, if you look at the graph above, what would be on the vertical axis of the graph? What order is this reaction? First order.
Because it's 1 and 1 and you add them, so it's 2.
Okay. All right, Ln of the concentration. So Ln of the H2O2 concentration. Or you could do log base 10 if you really wanted to. Units here, units of the rate constant. And here is what it would look like uncatalyzed and catalyzed. Here's the next problem for an aqueous solution. Methanoic acid and its dissociation. So from this we can get the pH from the dissociation. And then the equilibrium constant expression, that's just the K expression. And then find the value of Ka from that data. And then we continue on this in part D. And here is E and F with some additional problems here for E and F. This is where your ice table comes in. And your Henderson-Hasselbalch, or your Henderson-Hasselbalch, I should say. So these are some problems you'll be going through, practicing these before Friday. This will be on YouTube.
Is there somewhere besides YouTube I can find them? That way I can like go to where I want to go. I know, but that's more work than having a PowerPoint. Then you could see.
Sorry, Lo-Chan, I don't have a PowerPoint that I can post right now.
I know.